Welcome everybody for joining us on this rainy evening, in Denmark at least, for this webinar on displacement mapping, this new feature in KeyShot 8 that I am really happy about. I think it's really cool. Before we begin, this webinar will be recorded and posted to YouTube afterwards. So if you missed something or want to rewatch it, you can always go to youtube.com/KeyShot3D and see it again. And feel free to ask questions here live in the chat window or in the YouTube comments as well if you're watching it there. I am, for those of you who are interested, presenting on a Threadripper 9050X CPU. So today's agenda is to talk briefly about what displacement mapping is, and then I'm going to show you some examples of what you can create with displacement mapping. And then we're going into some live demo showing a bunch of different ways that you can use displacement mapping for some different things. And in the end, we have Q&A time for any questions you might have regarding displacement mapping. So what is displacement? Displacement mapping is a way to use a 2D texture, a grayscale 2D texture, to actually modify the shape of a piece of geometry. So you could say it's like a bump map, but instead of simulating the height differences based on these grayscale values, you are actually modifying it. So here on the left side, we have this perfect sphere. And you can see here in the mid, we have added this noise texture to it, black and white values. And when we add that as a displacement map, you can see how that affects the shape of this object. It's not perfectly spherical anymore. We can see how it's getting distorted and displaced by this 2D texture. So it's acting like a bump map, but just actually distorting the geometry. We can see here two examples. Again, it's based on this perfect sphere. And here we have the displacement, and we can really see, if we look at the silhouette, how it's being actually distorted by this map. Whereas the bump map, when we look at the center here, looks fine, and it looks like this surface is being distorted. But once we look at the edge, we can see that it's still perfectly smooth, and at least for larger surface heights, it starts to look fake when you have this perfect silhouette. So this is where you really want to use displacement map when you have details or want to add details to your materials that are so large that they will actually distort the silhouette of your geometry. So here's an example by Alexander Kaula, which is just a displaced sphere with some cool materials on it. And we can see, if we jump to the geometry view here, that it's actually just a couple of spheres. So by using a displacement map, you can create some really interesting geometrical shapes really fast, as you will see later as well. We have this one by LM6 for Remember as well. And we can see here that he has used a pretty cool map. Looks like lava or something like that. But again, it's just a perfect sphere being distorted by a 2D texture, and we get this kind of really cool effect. Something on a bit larger scale. This is a flat plane being displacement mapped, and together with a diffuse map, I believe we get this pretty cool landscape just from a 2D texture. And again, another example on that by John Seymour. These hills and this ground over here, it's all a displacement mapped, totally flat plane. So some pretty cool examples. We also have this one by John Seymour, again, using just displacement mapping and a couple of other maps to create this electronic piece that looks really cool because we have this actual displacement of the geometry. And again, another example of that. And here we really see how you can create something cool. If you also have a diffuse map that fits with the displacement map, then you get this. You can get these really detailed looking models really fast. Again, another example using the same methods. And we also have this one here from Camomads. And we can go in close and see how the details are looking really, really good. So again, this is just a flat plane being displaced by a 2D texture. And if you have, or when you have matching diffuse and roughness and specular maps, you can create some really cool details. And this is example I really, really like. This is one thing that where I feel that displacement mapping is really useful as well. This is by Will Gibbons, 3 different pen designs. And he's using procedural textures to displace the shape of this pen. And really quickly, by doing that, he can assess different designs and see how they will look. And I will go into an example later on how to create something like this and show you how fast you can do different iterations compared to if you had to model all these different designs in your CAD software. So another example you can use displacement for could be the tire on a wheel, like the pattern that you have here. So here I have mapped this mesh procedural, as you see here. And once I use that as a displacement map, I get this kind of effect. So by going back in and changing the settings for this mesh procedural, I can get some other designs really fast. And with that, let's jump into the live demo stuff. So first of all, I will be going through some basic setup and settings. Then I will show you how to avoid these jagged edges that you might encounter or probably will encounter when working with displacement mapping. I will show how to use displacement mapping together with PBR materials. This is one place where you will encounter displacement maps when you grab PBR materials online. I will show how to use them together with a 3D scanned model. This is also a place where you often see displacement maps. And then I will show you how to use procedural textures for displacement mapping and show how to use that for creating some different designs. So we have this pin here, we have this grill, and I hope that will show you the flexibility that displacement mapping can give you. And in the end, I will show that displacement mapping also works for animated textures, so you can create something like this, where you have displaced raindrops raining or running down a window, and also something a bit more abstract using procedural animation, like that. All right, so let's jump into KeyShot and have a look at the basic settings. So here inside KeyShot, I have this red plane. That's my ground plane, just to show or keep track of my ground where it is. And then I have this blue plane. And onto this blue plane, I want to map a texture looking like this. So it has a background that is 50% gray. Then we have a complete black, a 20% white cube, a 40% white, 60% white, 80% white, and then full white. And with that on my model in here, we should be able to see how the displacement mapping works. So let me open up the graph for this piece, like that. And let me drag in this texture. Cool. So to add a texture to get a texture to work as a displacement map, what you have to do inside the graph is to right-click an empty space, select geometry, and select displace. This will give you the displace node that you need to attach to the geometry input of this new material root node inside the material graph. And with that done, you can take the texture and apply as the displace texture, like that. So before I go into the display settings, I want to make sure that my map is sitting correctly on my plane here. So I hit C on the keyboard to view that. And let me close this one down. And Let me planar map this on the part. Let me move the texture fit to Y, and let me rotate it like that. All right. So now I double click on my displace node here, and that brings up the settings for the displacement. So by default, the displacement height is set to 10. We have an offset of 0. We have a triangle size of 0.1 centimeters. And we have max triangles and also a checkbox for triangle size in pixels. But for now, let me try and execute this geometry node, because when you work with geometry nodes, you don't see the updates right away. It's not interactive. Once you are ready with your settings, you have to hit the execute geometry node button here, or the geometry nodes update button up here. Cool. So when I do that, it calculates how the mesh should look like, and we can see that we get something like this. And if I hit C on the keyboard again for this texture map, we can see that the black values of this map stays at the ground plane. And the brighter the areas are, the higher they will get displaced. So the completely white values will be displaced with the height that we have set here, meaning that this plane up here, or this part up here, is now 10 centimeters above the ground. And depending on the values, they will be closer to the ground. You might notice that it's not being interpreted linearly. So even though we have even steps between these different grayscale values, it's not like being displaced in a linear manner. And if you want that, what you have to do is to go into your texture, into the texture settings, and here in the contrast settings, drag that down to 0 and execute the geometry nodes. And once it's done doing that, we should see that it's now being displaced in a linear manner. All right, so if we want to not displace it this much, we can go and type in another height. So let's try 5 centimeters. This will bring it down to half the height, so around here, like that. And if we type in negative, we will see that we will get the displacement in the other direction. But no matter the settings we do for the displacement height, the black areas always stays at our ground plane. If you want to adjust that, maybe you want the 50% gray of your texture to be at the ground plane, what you have to do is to use this offset slider. So let me bring this back to positive 5 centimeters, and let me put in 0.5 for the offset. And by putting in 0.5, that means that the 50% gray will stay at 0, and black will go downwards and white will go upwards. So let's try and execute that. And here we go. We can see that now the 50% gray of the map, the area here, is now at 0, and the darker values are being displaced downwards and the wider upwards. If we take this to 1 and execute the geometry, take the offset to 1 and execute, we see now that white stays at the ground plane and the darker areas get displaced, and the black values will be displaced 5 centimeters. So a few different ways that you can adjust how the grayscale values of your map should be interpreted into this displacement of the geometry. Let me execute this. So when you use bitmap textures, you have the option to change the contrast to 0. But if we go and have a look at this disk right here, so it has been created using this part up here. It's a multi-material, so I have another material down here, but don't pay attention to this for now. We have this disk displaced by a procedural texture. And if I take this down to 0, like that, and look at this, we can see that it has been mapped with this color gradient, again going from black, 20% white, 40, 60, 80, and full white. And when I displace this, whoops, let me double click the displacement node. Let's take 5 centimeters and bring it upwards. Again, we see that we don't have this linear interpretation. And if you want that for a procedural texture where you don't have this contrast slider, what you can do is to add in a color adjust node between the displace and the texture. So I right click this connection here between these two and select utilities and select color adjust. And in this one, we have a contrast slider, and I have to set that at 0.5. So not 0 as you would do with the bitmap textures, but 0.5. And when I execute that, we will get this perfectly linear interpretation. So just a heads up on that. So let me jump back to this one here and into the graph and into the displace properties. So we also have triangle size. If I zoom in close, we can see that we have this jagged edge, and we can see that we have these triangles. If you want to assess the polygons of your displaced mesh, what you can do is to right click, go to materials, and add in a wireframe material and place that as the surface in this material root node. And then you will get a preview of all your triangles. So the triangle size defines the size of these triangles. So if I take this down to 0.1 centimeter instead of just 0.01 centimeter instead of 0.1 centimeter, we will get some smaller triangles and also more triangles. So if I select my real-time view and hit H on the keyboard to show my real-time or the heads-up display, we can see that at the moment we have around 100,000 triangles. So if I take this down as I did and execute the geometry, you will see that both here in the real-time view, we will get smaller triangles, and we should also get a way higher number. So now we have 4 million triangles, and they are way smaller. Cool. So this is one way that you can improve the quality of your displacement map, among others that I will show in a minute. But before doing so, I also want to tell you that we have this max triangle setting, and this is a way to put a upper threshold for the number of triangles that you can have in your scene. So as you see, if you use a really small number, you really quickly can get a really high number of triangles. And if you want to set a upper limit on that, you can use this max triangle number. So this number is in millions. So right now we have a limit of 6 millions, and I can take that down to, let's just say 1 million to do it of this demonstration. So if I execute the geometry nodes now, we see that we now have 500,000 triangles, and it's not as dense as before this mesh. So this is not the exact number it's going to stop at. It's more like a guideline to tell KeyShot that you can't exceed this limit. Then we also have this triangle size in pixels. Let me apply this material back again like that. And let me go ahead and delete this wireframe material. And to show this one, I want to use another model I have here in the scene. So let me hide this one and let me show this one called edges. So we have this flat disk. If I go to my material graph, we can see that I have my displace node connected to the geometry input. And I have this map, grayscale bitmap texture added to the displace. And if I go ahead and displace this, we get a pattern like this. So you can see right now the triangle size is way too big, but to show this triangle size in pixels, what it does, let me turn it on, and we can now see that instead of centimeters, we have pixels. And you typically would want to use a bigger number for that. So for this demonstration, I will go with 10 pixels. And when we use triangle size in pixels, that means that it's based on the distance from the camera. So The geometry further away from the camera will have bigger triangles, and the closer they are to the camera, the smaller the triangles will be. So let's try and execute this. Here we go. So now we see that the quality is better here in the front, and then it gets more coarse as we go to the back. And this gets really visible if we add in this wireframe material and add as the surface like that. So you can see it already here. It's denser down here and it's getting bigger and bigger. And when we zoom out and view it from the top, you can really see this difference in the density of the triangles. So this is a thing you can use when you have large surfaces or doing like a landscape where the details would be so small in the background, or maybe they are being blurred out by depth of field or something like that. Then you can save yourself some polygons by using this triangle size in pixels. But remember that it's calculated depending on the camera angle when you do it. So be sure to pick the right camera angle before executing the geometry node. So we get these, let me go back into the graph. Let me delete this wireframe material. Let me add in the plastic again as the material. And let me zoom in like here. And let me change the triangle size in pixels. Let me disable that and go with 0.1. So when you want to get rid of these jagged edges, there are a couple of things you can do. One thing is to decrease the triangle size, so make the triangle smaller. So we could go to 0.001 centimeter and execute that. And the smaller this number is, the longer it will take. So I like to start with a large number and then take it down only if I need more detail. So we see now that it looks better than before, but we still have some things going on in the surface. So let me enable my region view. So that will calculate a bit faster. So we could have a look at this edge here. We can see that it's not looking perfectly smooth. Another thing you can do is to increase the max triangles. So if it doesn't help to make this smaller, if you don't get any more triangles, when you take a look in the heads of display, you would have to bump this up. So right now we are below that threshold of 12 million. But if this was around 12 million, I would try and put this up to maybe 16 or even higher and see if that will help me give me some more triangles. I think in this case, it won't change anything, but let's see. All right, we got some more. So actually this one was putting a limit on our triangle size here, but it took also a bit longer to calculate. So let me put that back down to 12. Because another thing you can do is to take or be aware of your texture maps. Make sure that they are in a high enough resolution. And then also, if possible, use 16-bit TIFF files or 32-bit EXR files if you can, instead of JPEG files. So I have this file as a TIFF as well. So if I go ahead and load that in, this TIFF file instead of the JPEG, and update the geometry node, we should also see an improvement in the quality. So yeah, it got actually quite good, but we still see some tiny artifacts on the edge here. So a third thing you can do is to add a bit of Gaussian blur to your textures. So inside Photoshop, I took this texture. This is the TIFF file. You can see that it has some really sharp edges all around. And inside Photoshop, I added some Gaussian blur to it. So this is the version with the Gaussian blur. We can see that it's not much, but just a tiny bit. And that allows the displacement map to fade a bit more between these different values. And this will give us a more smooth result as well. So let's add that in as the map, take the one with the Gaussian blur and hit open. And execute the geometry node. So pay attention to the edge down here. We can see that it's really jagged at the moment, and also the corner here and so forth, and see how that Gaussian blur will improve the quality. All right, here we go. So now it's looking really, really good in my eyes. It's looking really smooth and everything. We don't have these artifacts anymore. So these were some tips to make that look better. If you are using a procedural texture, like here, let me open up the material graph for that, and let me switch to my falloff example here, because when you use procedural textures, you don't have the option to add Gaussian blur. But what you can do instead, for at least some of the procedurals, is to add a bit of falloff. So at this point in time, we just have a completely black and white map raising these cylinders from the surface of this flat disk. And we can see that the edge is quite jagged, even though we have a ton of triangles. So what I can try and do here is to go down to the settings of the mesh and make sure to add a bit of falloff. So let's try and add 0.2. And let me show you one thing here as well. So whenever you change some settings in a texture that is connected to a displaced node, or change some settings inside the displaced node, you will also get this small icon telling you that you have made some changes relating to displacement, and it have not been updated. So hitting this one would be the same as hitting execute geometry node. It's just sitting here in the corner of the real-time view. So let's hit this one this time and wait for it to calculate, and pay attention to the edges here and see how the falloff will help to make it look a bit better at least. Here we go, way smoother. We have the same amount of triangles, but by adding that tiny hint of falloff, it smoothened out these edges.
Hey, Esben, there's a bit of a lag. Maybe you can try and disabling self shadows to help speed it up a bit.
All right.
Great, thanks.
Yeah, no problem. So that was actually it for the basic settings. So I will move forward. Let me close this one down and have a look at using displacement maps for PBR textures. So in this scene, I have this brick wall, and it's based on textures that I downloaded on Polygon. So if I go to I went to Polygon and grabbed this bricks 01 texture, and when you grab textures online, like these 3D scan textures or PBR textures, they often comes with a displacement map. And if I click that, we can see that it's this black and white map describing the different heights of these bricks. So inside this scene, I have the wall, all the textures except the displacement map. So it looks quite nice, but if I get in close, we start to see that it feels a bit flat, and definitely when we view it from the side like this, it looks fake. It gets really visible that it's not, that it's only a really flat plate. So we can improve that by adding the displacement map. So I right click this material and select edit material graph. Let me move that over here. And I have everything set up, the color texture, the reflectivity, and the gloss, and the bump. Won't cover that at this point in time, but let me right click and add in the displace node by going to geometry and selecting displace, and apply that to the geometry input of the root node, like that. Then I go and grab my displacement map, like that, and drag to the graph. So before I add it as displace, I want to make sure that it's sitting correctly, and I believe I have to rotate it 90 degrees. Nope. Let me check. Seems like I have to planar map it. That's what I did. Here we go. So now it should fit perfectly with the other textures here. Yep. So let me add it as displace. And let me go with the default settings. Let me lower this number. I like to have it low from the beginning and hit execute. So looks really strange. And first of all, we're displacing way too much. So be aware of your units. This scene is in meters. So this is 10 centimeters, and we probably only need to displace this by 1 centimeter. So let's do that, 0.01 meter. The triangle size, again, 10 centimeters for one triangle is way too big. So let me take that down to 0.001. So we at least have 1 millimeter. But otherwise, let me try and execute it again. All right, starts to look nice. If or when I assess the displacement map on my model, I like to go ahead and disable these other maps to better be able to see what the displacement map is doing. So now we only have the displacement map, and we can see when we go in from the side how these bricks are now coming out in different heights from the wall. And I think it looks pretty nice, so I won't adjust this further. And I think this is a good example also showing that displacement maps and bump maps or normal maps work really well together. When I apply the normal maps, you see that it adds another level of smaller details. So in this case, the displacement map is taking care of the bigger surface details, and then the normal map takes care of the smaller details. That wouldn't change the silhouette of the material anyway, or the geometry anyway. So when I add these other things back in, the other maps, we get this wall material that looks quite convincing, and we have the shadows from the bricks depending on our lighting as well. So something that I use displacement map for a lot is to add it to these different materials that you can grab online. Another place where you will meet displacement maps is when you work with a 3D scanned model. So nowadays, 3D scan models becomes more and more used, I think. So in this case, I have this 3D scanned trunk of a birch tree, and it looks quite nice. If I open up the graph, we can see that we have a few different textures going on. We have this diffuse map. Oops. We have this roughness map, and we have this bump map. So if I go ahead and disable these three, we are left with the base geometry, and it looks like that. So quite basic, and the normal map does a great job doing like that. But still, when we look at the silhouette, it's a bit basic, a bit simple. So by adding in the displacement map, we can get some more details. So let's do that. I will go to my folder and locate the displacement map. And in this case, it's a, let me see, 32-bit EXR file, and it's almost 300 megabytes. So it takes just a few seconds to load. So this one is super high res and super detailed.
While we wait for that to load, Esben, there was a question from Sandy. Yep. Are displacement maps and height maps the same thing?
Yeah, so sometimes you will come across the term height map, and actually this one here is called height as well. But I think they are interchangeable, and they both describe the same thing, at least to the best of my knowledge. So we have the map here, and when you have a, let me just hit C on the keyboard to preview it. When you have a 3D scanned model, the textures are often UV mapped. So make sure that you go up and change the mapping type from box to UV. And when I do that, it jumps into perfect position, and we can go ahead and add that as a displacement map. So I right click, go to geometry and add in the displace node, drag that to the geometry input in the root material node, and then add this texture to the displacement. And again, let's just try and go with the base settings and hit execute. And I know this will be way too much, but just to show you how crazy stuff you can do with the displacement map, it's really fun to see sometimes to really crank these out to the extremes. So looking quite good, but it's way too much displaced at the moment, and also a bit too rough. So let me bring this one down to 0.5, so 5 millimeters. Let me take the triangle size to 0.001, should do, and then hit execute. And now you start to see how that looks. We get this more detailed silhouette, but it looks a bit flat on these areas. But this is because, again, this is an example where displacement map and the bump map is made to work together. So when I enable the details coming from the normal map, we see that it makes perfect sense. And now we have this really detailed looking piece of geometry. So when I enable the roughness map and displacement, or sorry, the diffuse map, we get this really detailed trunk that you can use, place your product on it, or use it as a background element or whatever, and it looks pretty good. And that brings me to the procedural displacement mapping ways that you can use displacement mapping to do design iterations or alterations quickly compared to how long it would take to actually model it. So here I have this speaker, and we have this speaker grill, and it looks quite nice. But when we zoom in close, we start to see that it's actually paper thin. We can see like the holes through each other, and we could make it look a bit better by using displacement map. So if I right click this texture and go to edit material graph, we can see that it's quite a basic setup. We have an anisotropic material, and we have this mesh texture cylindrical mapped on this piece and working as the bump map and opacity map. So if I take these two away, you'll see that it's a fully enclosed cylinder. So we can use this map for displacement as well. So I right click, go to geometry and select displace and add that to the geometry input. And I'll take this map and add to the displace. So, oops, in my settings here, I will go with negative 0.5. So let me take a look at the map here. What we want is these circles. I want those to go inwards. So what we control the height of is the white areas, and the black stays put. So I want to invert this map before displacing it. So let me right click this connection, go to utilities and select color inward. And if I hit C on the keyboard for that one, we can now see that we have this. So black will stay put and white will be displaced, and I want to displace it inwards. And that is why I go with negative 0.5. And let me change the resolution like that, 0.01. I think that should be good. And let me try and execute this. So I think all the holes are a bit heavy to process, but it will eventually get there. And when you work with displacement mapping, the setup time or calculation time might take a while, but once it's done, it works perfectly smooth. So it's only in this calculation time you have to wait for it. So I think this looks quite nice, but we can't see the fabric mesh that we have beneath. So this model have this mesh, and then we have another piece of geometry with this fabric material underneath. So just as before, I can enable this opacity map, enable this as an opacity map again, and we can see the fabric which underneath. But we see that the transition is a bit unclear. Let me activate my rendering region like that. And instead of using this texture, the same mesh texture, to act as an opacity map, I can create a duplicate of it like that and drag to the opacity, and then make sure to unsync it so the changes I do now won't act down here as well. And then I can go down to the fall off, take that down to 0 to make this completely sharp transition, and then also scale the shape diameter down so we get the sides in our holes to show, and it only cuts out the whole of this material like that. So I'm fully aware at the moment that this is a pretty rough looking displacement map, or displaced geometry, but what I would do would work with the fall off and add some more triangles to make this look more smooth. But for the sake of time, I will stay with this for now. So if you don't have the extra piece of geometry for the cloth underneath this anisotropic material, what you could do instead would be to create everything inside one material. So if I go to my fabric material here, I open up the graph for that and grab these 3 pieces and hit Control C to copy them, and then go back to the graph for my mesh material, and then right click and select paste like that, and add this as a label. Oops, like that. So now we have both materials inside the same material, so to speak. So instead of using this mesh as the opacity for the anisotropic material, let me delete this. I can use it as the opacity for my fabric material. And this is the exact opposite of what we need. So I will right click, go to utilities, and select color invert on this connection here. So this will give me the exact thing I'm looking for. We have this displaced mesh with the fabric underneath in just one texture. And once we zoom out a bit, we also don't see too much of these rough edges, and it starts to look really good. And we see the depth of this material, and you can adjust the depth of this or the thickness of this material, and the fabric will follow, and you can go in and change the shape of your procedural texture. So change the shape to anything you want to, and change the size and spacing and everything, and it should all follow. You probably have to update it here in this mesh as well, but otherwise it's really quick to do some different design alterations. So let me show that on this pen as well that we have. Here we go. So we have this pen here, and then we go into the material for this black part. Let me bump up my CPU usage like that. And then in here, whoops, I picked the ground plane like that. So we have a plastic material, we have a bump map, and we have a roughness map. That's all. So here I want to add a displacement map. So I right click, go to geometry and select displace, connect that to the geometry input of this root material node. And then I right click and go to textures and add in a mesh texture. So I hit C on the keyboard to preview that. And I will change the shape from circle to lines. And I will change the mapping type to cylindrical and center on the part. And let me hit move texture to, whoops, be able to map this to the Y position like that. So let me take the scale down a bit. Let me angle the UV to do something like this. And let me add a bit of fall off. So let's try this. Let me add this to the displace. And definitely don't want to displace it 100 millimeters. Let me do -1. So again, I want the black areas to stay put and then bring in these white areas. So I go with -1. And for the triangle size, I think 0.1. Let's start with that. And let me execute the geometry and have a look at what we get. All right, so I could go ahead and change a bunch of things, but let's just keep with this because I want to show how you combine different maps to use as a displace. Because sometimes you want to add or combine several maps to act as the displacement map. And you can only have one displace node, so you have to do it before putting them into the displace node. So what we can do here, if I want to fade this in so it's not displaced in the beginning and then it's displaced and then not displaced again, is to add in a gradient texture and combine them using the composition node. So I can right-click this connection, go to utilities and select color composite. And then I can go ahead and right-click an empty space again, go to textures, go to color gradient, hit C on the keyboard to preview that, and probably hit move texture and rotate it 90 degrees like that. And then add in another color stop and make it black. Let me do this one white so it fades from black to white to black, and let me move this in just a bit. The same over here. And I probably have to move it up a bit. So could be something like this. And what I like to do here, I think you can combine them in several ways, but what I like to do is to add this gradient as the source alpha and then hit C here to see what it looks like. We want these areas to be completely black, and to do that you have to go and change the background color to black. And then you get this where it's not displaced, then the white areas will be displaced and then it will not be displaced. So let's go ahead and execute that, hitting the button up here. And we now get this really cool effect where this displaced piece of geometry fades in and out again. So when you have something like that, it's really quick to go in to your mesh, change the settings, maybe angle it even more, adjusting the size. Oops, not the shape angle, sorry. The pattern spacing, like that, and then execute again and see your new changes. So in comparison to modeling all these things, I think it's a really quick way to do some design alterations and see what will be cool looking. And once you're happy about a design, you can actually go ahead to a file and export this as these different 3D formats. So you can bring it into your 3D software and use as a base mesh or for 3D printing or anything like that. So here's a design I did earlier today, and I brought that into Modo. So I can use that to actually build the geometry if I need that, or just use this geometry as is for whatever my need would be. And that brings me to the last part. So the displacement also works with animation. So I have this file here, and let me just show, let me show the video once again. Yeah, so we can see that we get these hexagonal pattern appearing and then disappearing again. And what I have done, if I unpause this and do like that, if I play the animation, you won't see anything. So the displaced or the animated displacement won't show when you scrub through the timeline, but once you render it out, it will be calculated. Or if you come to any specific frame and hit the update geometry nodes, it will be updated to that specific frame, so you can do some checks along the way and see how it looks like. So just to really quickly show you how this is set up, I will go to the material graph, and this part up here, it's just the base material, so don't worry about that. Everything exciting in this one is happening down here in the displacement. And if I hit C on the keyboard, on the color composite, we can see that we have this. But actually, let me start from the other end. We have this mesh on the entire sphere. It's been spherically mapped. And then we have this color gradient that has this number fade animation node into the shift value. And that means when I play the animation, it moves across the model like this. And once I use that as the source alpha for the mesh texture, we get a map looking like that. And this is the map that has been used to drive the displacement. So we get this effect of these hexagonal bumps coming in and out of the surface. So the concept is the exact same for the raindrops that I showed as well. Let me grab this scene. Here we go. Open file. But instead of using a procedural map, it's using a sequence of raindrops. I can show you that here. So we have these black and white maps here, which is a sequence of raindrops going down through a window, and it's been used as a displacement map. So the white values will be displaced and black will not, and the gray a bit less. So when we look at this side, we can see that these raindrops are actually coming a bit out of this glass surface, and it's being combined with a roughness map as well in the same way, so that the places where the raindrops have been is also more clear than the other areas. But again, if I open up the material graph, we can see that we have this all these images as a video map for the displacement. And again, I can, if I hit C on the keyboard for this one, the video map, you can see how that looks on the window, and then that will be calculated as the displacement map once it's being output from KeyShot. And that concludes the presentation and ends me with this Q&A. And as a last tip or information, this has also been created using displacement maps, so it's just a flat plane. And I created this really fast displacement map text in Photoshop by doing a 50% gray background and then a gradient on the colors or on the letters going from black to white, and that gives you this quite fun effect. So thanks for your attention, and let me know if you have any questions.
Thanks, Esben. That was really fantastic. And yeah, that is a fun image. I think we should use that at the end of every webinar.
Yeah.
Yeah, I mean, those examples were really great illustrations for how to use displacement mapping. And I think you did a great job at explaining them. You answered most of the questions that came in. There was one from Bill that was more of a workflow question related to working with maybe more complex scenes with multiple displacement maps. So the question was, it appears that displacement has a hit on file size and refresh time. So it seems logical to disable each displacement map as you proceed through the scene, then re-enable them all prior to final visual or render. Do you have any thoughts on that? Have you had any experience working with multiple displacement maps in a scene?
I haven't used it like in larger scenes so far. I think file size wise, I think Dries told me that it won't have an impact on the file size because it will be calculated once you open the file. So it's been loading into the RAM. So it's actually not storing the all the triangles that the displacement map creates. So file size shouldn't be an issue. As far as performance goes, I mean, I have had scenes with more than 1 million triangles and it still ran pretty smooth. So I think you can have quite a lot of details without getting too many problems at least. But again, I haven't done too many scenes with a lot of displacement maps going on yet.
Yeah, I also agree with that. That's one of the great things about KeyShot is that it can handle a very high number of polygons. Something you might be seeing, Bill, maybe you're working with meshes, maybe there's a lot of complex shadowing and areas of indirect illumination that could be slowing down the scene. So just as I asked Esben to disable the self shadows when he was working, maybe that is something you can look into to improve the performance working with complex scenes and multiple displacement maps.
Yeah.
He had another question. Can you use just any texture, a RGB texture as a displacement map, or does it have to be grayscale? If you can, then should you change it to grayscale using color adjust node, or what do you think about that?
I think I haven't tried, but I would guess that if it works the same way as it does with bump maps, that if you add in a color texture, let me see if I have one here. Just take this one. I think it will automatically adjust it to a grayscale image. Let me check.
Yeah, so I think
Yeah.
when you need that high level of control, then you'll want to use a grayscale map. But if you're looking at just adding surface imperfections and things like we see here that don't necessarily need to be defined by strict units, and I think it's totally fine to work with RGB maps and color maps. And where did you get the video map for the raindrop texture?
I think I grabbed that on Gumroad sometime. I think if you search for raindrop roughness or something like that, raindrop bump map, then it will show up on Gumroad. Don't remember exactly, but it is definitely Gumroad. I remember that.
Okay. Yeah, I just wanted to mention that you were using the latest update of KeyShot 8.1, right? And there was a few changes and improvements from 8. Maybe we could just point out a couple of those. I know you mentioned them in the demo, but yeah, there were a couple small changes.
Yeah, so I at least what I remember is this triangle size in pixels. That's a new one in 0.1. But otherwise, I think you will have to fill me in here.
Yeah, it was the real-time view indicator icon that allows you to refresh. So that's new for 8.1. And then also there was a change in behavior where in KeyShot 8, refreshing the geometry node in the material properties refreshed all of the nodes, but now in 8.1, the one that's in the material properties only refreshes that material. Yeah,
that's true.
And then there were some improvements as far as reloading maps when changing materials. So yeah, if you haven't updated to 8.1, I highly recommend you do that to get the improvements on the displacement mapping, and there are a number of other improvements that are outlined in the release notes. So yeah, have a read through those. We kind of took some extra time to include more information than we usually do, and we really want to be transparent with our process and show you guys the things we're fixing and the improvements we're making. So any feedback on that, we appreciate it. And do you have anything else to add before we wrap it up, Esben?
I can see that Jeff has posted a link to Gumroad, so I guess it's for the textures that I just talked about. So the people interested might have a look at that link just as a head up. But otherwise, I don't have anything else to add at this point in time.
Awesome. Well, thank you everyone for joining us. As Esben mentioned, a recording of this will be available at youtube.com/KeyShot3D. Go ahead and subscribe and like the channel. Check out all the other amazing learning content that Esben has been cranking out, and let us know what you think. Give us some feedback on what kind of webinars you want to see in the future, and we look forward to seeing you next time. Thanks.
Yeah, thanks for tuning in. Have a great day.